so we've got the period, 6 pi. We've got the center line, y equals 8. We've got the minimum, that's pi over 2 comma 4. Our goal is to make a sine or a cosine function that fits this information. Now notice it's your choice. You can do this either way. You can do this with a sine function or a cosine function. It'll work. It'll work out either way. So first off, we just got to decide. Do we want to do a sine function or a cosine function?
Sine.
I vote for sine. Anybody else? 2 votes for sine. All right, we're going to do sine. So we go with y equals
Plus 8.
a sine bx plus c, and then, yeah, d. So we're just going to start filling in information. Okay, the center line tells you d, so that's plus 8.
So you can go from the center line to the minimum from that.
Okay, now if this is the minimum, the distance from the center line to the minimum is 4, which tells us our amplitude must be 4. Now, we may have a minus sign in front or not, that we can decide later. But we know that it's got to be a 4 or a negative 4 for the a. Okay, the piece of information I like to use next is the period. Remember, 2 pi divided by b must equal the period. So you can solve that equation for b.
It's 1/3.
1/3. And the only thing we're missing then is c to decide what this is. Okay, so we got to think about the graph here for a little bit. I'm not doing an accurate graph. We're just going to kind of sketch it for a second. Okay, so this is 4, this is 8, this is 4. Now, at pi over 2, we're at our minimum. Well, I don't know if there's a c value or not. We only have 1 point. We got to visualize the rest of this graph. So you know this is a cosine. A cosine or a sine. Sine. That's the same picture. So we know it hits that point, and then it goes up to the top, and then it comes back down, and then it does the same thing back this way. Okay, we're just sketching it so we can look at it and talk about it. Now, if we're using a sine function, we got to decide what our starting point is. Okay? Do we want to use this point here, or this point here, or this point here, or this point here as our starting point for our sine? Anybody care?
Tough.
The first one. Okay, so this one there? This one here? This one here?
Yes.
1 vote. Well, let's label them A, B, C. 1 vote for A.
B.
1 vote for B. 3 votes for B.
C.
So we got 1, 3 votes. B is getting the most. Okay, so that's easy to fix. We'll put a negative on that.
What?
Yes,
Do it.
if you use point B, you got to have a negative A value, because if we start here, then we're going down to the bottom. So we're going to need a negative there. If we use point A or C, we can leave that being positive. All right. So we're going to use point B, because that was the winner there. I probably shouldn't have used A, B, and C, because we've got A, B, and C now for other things in here. So that's why I erased it. Anyway, we're going to use this point right here.
All right.
And that's going to be our starting point. That is completely arbitrary. Okay. Everybody in here could have used a different starting point. Because although we only listed 3, you could have used this one, or this one, or that one, or that one, or... So everybody could use their own starting point and have a valid equation. All right, now, if we're using that starting point, though, we've got to make it negative because we're going down first. What we we need to find out, and my graph might be bad here, this is just a sketch. We need the coordinates of that starting point though. We need to find out what those coordinates are, so we can figure out the phase shift. Because unless I did a really bad job graphing, maybe it could be at x value 0, but I have a feeling it's not. It's a pretty bad graph. If it's x value 0, we can put 0 right here and be done. But I don't think that x value is 0.
Can you?
So, how are we going to find the coordinates at that point? Well, I know the y value. 8. That's not the important part. The important part is the x coordinate. Ideas on finding the x coordinate of that starting point.
The scale.
Okay, use the scale. We know the period is 6 pi, so what's the x scale?
3.5 times, or
1.5 pi. 3 pi is over 2. 3 halves pi.
Yeah.
So that's exactly one scale marker to the left from this point here. Because remember, the distance between our points is always just scale. So if this is pi over 2, if I go to the left 3 pi over 2 from that, I will get to negative pi. And there is a phase shift. So now we can set negative pi equal to c over b. But we already know b is 1/3. So we got negative pi equals c over 1/3.
Wait a minute.
C equals. So what does c equal? Negative 3 pi or negative pi over 3? Negative pi over 3. You gotta multiply both sides by 1/3. Okay, now remember, it's bx minus c,
Plus C because it's opposite.
so it's, right, we're gonna have plus pi over 3. Yeah. We are done. All right, we gotta do secants and cosecants now.
Yeah.
We probably won't finish these. We'll get started on it. And tomorrow, tomorrow we'll need to finish the secants and cosecants, because we're also gonna need to do tangents and cotangents.
They never told me.
So that's our goal for tomorrow, is get through all of the other functions. Taylor's gonna give you a taste for it, with a few secants or cosecants. Then we'll have to do our quiz. Tomorrow we'll finish secants and cosecants. Start and finish tangents and cotangents. Looking ahead to Wednesday, it's not on the schedule on Angel, but there's going to be a group in-class activity.